In this video, I'm going to be taking an introductory look at some post-production audio processing techniques for correcting common issues that you may encounter with poorly recorded audio. There's many tools available to do this. Today I'll be using one called Logic Pro, but many of the techniques that I'm going to be covering are easily reproducible in other software. So let's get started. So perhaps one of the most common problems that you'll probably find when you're processing audio from video is the presence of unwanted frequencies. So in this first example, we're going to look at the problem of having too much hiss or high-end frequencies on a piece of audio and how you can use EQ or equalization to correct that issue. Let's take a listen.
So this is an example where I might have recorded at quite a low level and then had to boost it in post, and that's resulted in quite a lot of high-end kind of hiss. So to eliminate this, we're going to pop on some EQ, and we're just going to have a roll off on the very top end of the EQ to eliminate all this hiss that we can hear.
So depending on what software you're using, you may have an EQ that looks a bit like this, which is a graphic equalizer. You might be familiar with this style from hi-fis and things like that. Or you might have something that looks a bit more like this, which is what we call a parametric EQ, and this allows you to add or boost usually in a kind of bell kind of shape or a curve shape. And for this, we're going to be using the parametric EQ, and as we heard my colleague Joe say in the clip, we're going to look to roll off the top end. So what he means by that is, if we actually look at this little moving line when the clip is playing, we can see this is telling us what frequencies are existing in our audio at any given moment. And what we were looking to do is just to remove some of the very highest frequencies, which is where that hiss is. So we're going to be using something called a high cut. We can then just bring this down to start cutting off frequencies from the audio. If we go too low, everything's going to start to sound really muffled. So we just want to find a balance between it sounding clear still, but then also removing some of that unwanted hiss that you may be able to hear on the sample. And what I'm going to do is I'm going to turn it on and off like this so I can audition what effect the EQ is having and tell when it's about right. Now this isn't going to completely remove all of the hiss. There's quite a lot of background noise on the recording as it is, but it's going to help things. So it's not a complete fix, it's just about trying to reduce the problem to a manageable level.
So this is an example where I might have recorded at quite a low level and then had to boost.
So hopefully you could hear there the difference. If I bring it down too low, you'll hear how it starts to sound
So
really
this is
muffled.
an example where I might have recorded at quite a low level and then had to boost it in post, and that's resulted in quite a lot of high-end kind of hiss. So to eliminate this, we're going to pop on some EQ, and we're just going to have a roll off on the very top end of the EQ to eliminate all this hiss that we can hear.
So let's just take a moment to look at some of the controls and some of the terminology that you'll find really on all EQs. First of all, we have this number here. This is the frequency measured in hertz, Hz. And so low frequencies have low values. So the bottom range of human hearing, if you've got very good hearing, is roughly 20 hertz, going up to around 20,000 hertz or 20k hertz. And so this number tells us at what point the EQ is being applied. So in this case, everything around 6,700 and above is going to be gradually rolled off according to the curve that we set here. It's a little bit more advanced than you need to know, but there are different curve shapes, with lower values having a more gentle curve and higher values having a steeper curve. And then we also have a Q value. This is this bottom number here, currently 0.71. And what this does is it changes the focus, if you like, around the specific frequencies. So if, for example, I draw in another shape here, and if I have very low Q settings, it's going to affect a very wide range of frequencies, but I can focus this down to a very specific or narrow band of frequencies by going for higher and higher values. There are drawbacks and sort of positives to using low values or high values, depending on the situation. So when we're using very narrow frequencies, it allows us to be very precise and remove specific frequencies or boost specific frequencies. But that can sometimes sound really noticeable and kind of ringy. Whereas if we're using wider sort of bands, it tends to colour the sound across a greater range of frequencies, which can be beneficial. For example, you might want to improve all of the kind of high end, boost the high end overall if things are generally too muddy sounding. or if it's too bright sounding, you might want to remove those frequencies, but it's far less precise as well. So it's just about selecting the right kind of shape for the application that you're working on. So with our next example, we have the opposite problem. We have some low end frequencies. Let's take a listen.
So this is an example of where we might get some low-end problems. So for me here, this is traffic noise in the background, causing a low-end kind of rumble. So we're just going to apply some EQ and do what's called a high-pass filter, which is basically just rolling off all of that low end on the bottom end of our frequency spectrum.
So as you can hear there, I did what Joe suggested, and I'm this time applying a low cut or a high pass. It's just going to allow the high frequencies past everything above 123 Hertz in this case, and you can hear how much of a difference that makes removing all of that low end rumble.
So this is an example of where we might get some low-end problems. So for me here, this is traffic noise in the background, causing a low-end kind of rumble.
So let's take a look at one final example then of when you might need to remove a problematic frequency. Let's take a listen.
So this is an example where we might have a very specific frequency which is causing a problem. So we need to pinpoint exactly where that frequency is and pull it out on the EQ.
Now we could see here this little peak. This is the beep that we can see here as well. So that's the frequency that we need to remove. So to do that, I'm just going to set the frequency to be in line with that problematic frequency. I'm going to bring down the gain. That just basically removes the signal, the level of the signal around this frequency. And I'm going to make sure that I'm using a very narrow Q value here to just really focus in on that specific frequency as much as possible. So let's take another listen now, and I'll kind of compare it with and without so you can hear just how much of that signal has been removed.
So this is an example where we might have a very specific frequency which is causing a problem. So we need.
And just to show the difference, the reason why I've used a very narrow Q value is because if I did this, it's going to remove some of the frequencies from the voice and it's going to start to sound very unnatural and slightly hollow sounding.
So this is an example where we might have a very specific frequency which is causing a problem. So we need to pinpoint exactly where that frequency is and pull it out on the EQ.
So obviously this is a very, very extreme example. You wouldn't normally have to fix a problem as big as this, but nevertheless it shows that you can use EQ to remove problematic frequencies to a certain extent. Now, another very common problem when processing audio in post-production is too much variability in the volume level of the recorded signal. And as we'll see, this often happens when people speak kind of quietly like so, and then get very loud for short periods of time when they get excited or animated, and then often trail down to be very quiet. And the problem with that, of course, is that it means that for the listener, some parts might be too loud and other parts might be too quiet and kind of unintelligible. And you can see straight away the difference here between sort of the mid-level, the quieter parts and the really loud parts. Let's take a listen to the example and then see how we can go about fixing it.
So this is an example where you might have a clip where someone is talking quite quietly and then they start to get quite loud without warning. So they could be quite loud, but then they could go quite quiet.
So the tool we can use to fix this is called a compressor. This is the one that I'm using in Logic, but they all tend to have very similar controls. Now this one is a bit more complicated than the one you might typically ordinarily see, but the main controls you need to look out for is this one, the threshold. This sets the level at which compression is going to be applied. We then have this control, the ratio, that tells you how much compression is going to be applied. And then you finally have a makeup gain control, which adds gain back into the signal, because what we're going to be doing is setting a level and saying, okay, everything above a certain level is going to be compressed. That means it's going to have its level turned down by the ratio that we set here. And then finally, because we're making everything quieter, we might want to turn everything up at the end. So it's quite a complex thing to get your head around, particularly for novices and particularly if you're not coming from an audio background. But if I demonstrate how it works, hopefully that will give you some clue as to how you can apply it. So the first thing I'm going to do is I'm going to bring the threshold down let's say to minus 25 decibels. So any signal that now goes above 25 dB is going to be compressed. If it is, you'll see this meter go from 0 where no compression is happening, and you'll see how much compression is being applied in these numbers here. These numbers relate to decibels of gain reduction, so how much gain is being taken away from the signal by the compressor being applied. Now, because it's being compressed at a ratio of 1 to 1, i.e. nothing will happen until I start to increase this value. So I'm just going to set this up to about 4 to start with, and then we'll see the effect that this has.
So this is an example where you might have a clip where...
So this very first bit is already being brought down in level by 5 decibels.
So this is an example where you might have a clip where someone is talking quite quietly, and then they start to get quite loud.
Now you can see when it gets quite loud, it's actually then being turned down by 10 dB because it's basically about twice as loud as this section is here. So I'll just play that through again, and then what I'll do is I'll record, or I'll render all of that audio, and you can see how different it looks. But you can hear straight away that there isn't that much difference in terms of the output of the volume once the compressor is applied.
So this is an example where you might have a clip where someone is talking quite quietly, and then they start to get quite loud without warning. So they could be quite loud, but then they could go quite quiet all of a sudden. So you might just want to level these out. Use your compressor just by bringing down the top bits of how I'm talking and compressing it.
So let's effectively render that compression onto that audio and take a look at what that has done to it. So now we can see by contrast, it's a lot more even throughout the whole piece of audio. And that means it's going to be a lot more balanced for the listener. It's not going to suddenly leap up and get too loud or too quiet. But there are perhaps a few places where noticeably it doesn't sound that natural because the level's kind of pinging around a little bit weirdly. And that's where some of these other controls like the attack and release, which basically tells the compressor how quickly and how slowly to apply that compression to that overall signal. And what I would recommend doing if you're using a compressor, and this is all very new to you, is to start by using a preset. So often compressors will have their controls set up for you for certain situations. So I might, for example, choose to try out this narration vocal, which is kind of like a voiceover setting. And then that will give me a good starting point from which I can then perhaps tweak some of these settings a little bit further depending on what my audio needs and what it has to do.
So this is an example where you might have a clip where someone is talking quite quietly.
So at that moment, this isn't being compressed at all with these settings. Let's see what happens when it gets to the louder part.
And then they start to get quite loud without warning. So they could be quite loud, but then they could go quite quiet all of a sudden.
So let's just render that by comparison. And so you can see it's still quite variable. It hasn't really done enough to kind of even this out. It's not as bad as the other one was, but it perhaps could be still a little bit more even. So in that case, we might just need to bring down the threshold, perhaps increase the ratio slightly. And we can kind of keep doing that until we get something that's closer to what we want it to be. So we can see that has made a slight improvement. It's not quite as varied as this example, the difference between the loudest and the quietest sections, we can see that. And that may be how you want it, depending on what the video is about and the type of audio that you're working with. It might be really important to have quite a lot of dynamic range, so difference between the quietest and the loudest parts. If someone's telling a story, for example, it might be that you really need that dramatic emphasis. If, however, it's more something like a tutorial or a podcast or something like that, where you want the audio to be a lot more linear in nature and not really leaping about too much in level, then you might go for something a bit more dramatic and go for something that comes out a bit flatter, with the trade-off that it might sound a bit compressed. It might sound a little bit unnatural in certain situations. Now finally, I mentioned that there are some more advanced tools for dealing with audio issues, and specifically there's a range of tools called RX, which is made by a company called iZotope, and they produce a range of different plugins that deal with different audio problems. And they are really the industry standard for audio correction and restoration. So previously we saw how there was some audio recorded with an annoying alarm in it. And the kind of basic way of tackling this was to use a very narrow EQ cut around that frequency to not get rid of it entirely, but very much to reduce the level of that signal.
So this is an example where we might have a very specific frequency.
But now what I'm going to do is use RX7. And the way that this works is it allows you to learn the profile of the kind of noise that you want to get rid of. So if I just kind of grab some audio just around this particular area here and learn this, we can see the profile of the audio in that particular place. And then we can actually just reduce this and basically kind of subtract that signal from the rest of our signal. And this is a much more accurate way of reducing those frequencies in our signal. Let's take a listen.
So this is an example where we might have a very specific frequency which is causing a problem. So we need to pinpoint exactly where that frequency is and pull it out on the EQ.
And so again, whilst not completely 100%, again, this is a very extreme example, but you can hear straight away how much better a result you can get using some industry standard tools like RX for removing, in this case, an unwanted noise.